As the development of a computer system, the computing environment evolves as well. At the very beginning, the traditional computer is standalone as general purpose machines. Under this kind of a computing environment, the computer can only do very standard tasks, such as read the input from the hard disk or type in the letters from the keyboard. Then the computer will do the computation according to the input data, then generate the output values and show them on the screen or write back to the hard disk. However, nowadays the computing environment is quite blurred because most systems they interconnect with each other. For example, the mobile computing, such as our cell phones, smartwatch, tablet, they belongs to this kind of a category. So in most of the case, they have embedded with additional sensors such as video camera, GPS sensor, gyroscope sensor, or accelerometer sensor, etc. For example, when you want to go to Memphis from Oxford, the GPS sensor can tell you where your current location is. So through the magnetometer, it can tell you which direction you should go, and the accelerometer can tell you what is your current speed. So unlike the traditional computing environment, so which use Ethernet to achieve the internet communication. So there are more options available for the mobile computing, such as we have a Wi-Fi, 3G, 4G, or even 5G now. So since we carry the mobile device here and there for most of the time, so the mobile devices cannot be charged all the time. So when we design the computing environment, we have to consider the energy efficiency in terms of a battery. So usually the people expect the battery can last for 10 hours, maybe 24 hours, or even several days. So you can see in this environment, we have a different type of wireless communication options, and we need to deal with different sensors and also beyond the normal I/O, which process the normal data. The mobile computing environment needs to handle multiple I/Os that caused by different sensors. For example, the video streaming data, the incoming calls, etc. And also, we need to care about the energy efficiency in terms of battery. Another computing environment is a real-time embedded system. So some of you guys may know that. So one of my research topic is Internet of Things, so which is highly related to the real-time embedded system. So unlike the traditional computers, which can with more computing power, so they are usually installed on the simple devices. Sometimes it's just like a simple chip. So these design objectives are very different from the general purpose computers. So their CPU computing power is very low. So for normal computer, um, can deal with as many as 64 bit of data. However, the simple chip can only handle 8 bit of data at a time. So, and for most of the case, they can only support addition and subtraction, may or may not be able to support the multiplication and the division, or even floating point computation. So for example, the smart light. So you can remotely turn on or turn off the light through the Wi-Fi network. Another very important feature of a real-time embedded system is the real time. So which means there is a strict time constraint must be met for correct operation. So some students may ask that for smart light, I don't really care about whether it can turn on or turn off the light within 100 millisecond or 1 second. So as long as the time is not 1 day or 1 hour, so actually we can tolerate the time delays. For a smart light system, the time may not be quite sensitive. However, how about the cars? So the auto drive system, which also use the real-time embedded system, and also it is a hot research topic in Internet of Things. So maybe a few years later, when you want to travel to another place, we don't need to drive the car by ourselves. So the car auto drive system will help us to do that. So when the car drives on the highway, the time delay becomes very sensitive. So because the very short of a delay may cause accident and take a people's life. So for that kind of a computing environment, strict time constraint is very important. Another emerged computing environment is virtualization, so which allows multiple operating systems, which we also call them guest operating system, to run as applications within other operating systems. And for the later operating system, we also call them as a host operating system. And the term VMM, which is shorted for Virtual Machine Manager, so running in the host operating system, which can provide visualization services to the users to allow multiple operating systems to be running in the single machine. So as I already mentioned that, so we will use a C programming language to do our programming assignments. So, and the C programming language actually is relying on Linux environment. So you can install the virtualization tools in your computer and then install Linux system as the guest operating system in your computer through the virtualization tool. Another systems called distributed systems, as we have mentioned a little bit when we compare the clustered system and the multiprocessor systems. So inside the distributed systems, it provides collection of separate, possibly heterogeneous systems networked together. So as we have discussed, there are multiple computer systems inside the distributed systems. So each one runs separately. So their computing environment may be consistent, same to each other, or maybe heterogeneous. So how those separated computers work together or communicate with each other. So actually through network as a communication path. So mostly using TCP IP protocols. And inside the distributed systems, so we may want to use some special operating system called a network operating system, which provide features between systems across the network. So for example, when we talk about operating system, the operating system needed to do a lot of management, such as process management, memory management, storage management, etc. So those managements are confined within single computer. So however, in network operating system, those managements need to be done among different computers. So even with different operating systems across the network, then you can imagine how complicated the system can be and how this management can be done actually through the communication scheme, so which allows different systems to communicate with each other so we can do the management as a whole thing across the multiple systems. And also, it can provide an illusion of a whole system as a single computer or single system. It will hide all the complicated details from the user. So when you use it, you cannot realize that they are working on the united entity of multiple systems. Beside the distributed system, there are other kind of computing environments client-server computing environment is one of them. The servers are usually very powerful computers with more computing power or special devices. The clients are less power devices such as the standard desktop, laptop, tablet, or smartphones. So a good example which use client-server computing is web service. So the web pages are stored on the web server, and the client device they can send a web page request to the web server through the web browser. And when the web server receives the request, it will send the corresponding response back to the client. Then the requested web page will be shown on the web browser. So this is the typical example which use client-server computing. And there are other kind of services which use client-server computing. For example, server system, which is commonly used by scientific computing. The users they send the computing tasks to the compute server. Then the computer server will do the calculation and then send the result back to the users. Another example is a file server system, so which perform like a remote version of a file system. So the users they can send the file to the file server, and later the user can retrieve the files. So when they need it. So when the user have updated version of the files, so they can update the files to the file server. It is quite convenient for the users. So as long as the internet is available. In client-server computing, each device has its unique role, either as a server to provide the service or as a client to request the service. And also, the single server can provide service to multiple clients simultaneously. However, the client can only communicate with the server. So among the clients, they can never talk with each other. So due to the simple architecture, so makes the client-server computing is quite easy to implement and maintain, especially for the client side. More efforts are put on the server side when implement the client-server systems because they want to make the server as efficient as possible. The peer-to-peer computing as a counter computing environment compared with the client-server computing. So there is no specific role for each peer, and each peer can act as both client and server because after each peer join in the system, it can request the service from other peers, and also it can provide service to other peers. Therefore, the P2P computing can support infinite numbers of users. And compared with the client-server computing, due to the fixed computing power of a server, so as the number of clients increased, eventually the server will be overloaded and out of service. So the most beautiful feature of P2P computing is the scalability. And also, unlike the client-server computing, so each client can only talk with the server. In P2P computing, each peer actually they can directly communicate with each others. Then some students may ask, so since the P2P computing is super good, so why we still have the client-server computing there? Actually, we can still see that there are a lot of services implemented through the client-server architecture. The reason is because that since each peer can freely communicate with other peers, so you can see that how many connections will exist in the system. And also you can imagine so how complicated the system can be. So which makes the P2P computing is very difficult to implement and maintain. So unless the scalability is the critical issue to be solved. So otherwise, people they will try to use the client server computing first. So I can give you a couple of examples which use P2P computing. So one is BitTorrent file sharing system. Another one is a SCAP online telephone system, which created by the Microsoft. And also Microsoft and Apple. So when they patch their systems, originally they will use the client-server computing to distribute the patch to the customers. However, due to the large amount of customer size, so they gradually move to the P2P computing because of the scalability feature.